Alright, hello, good morning. Today we're going to be moving on to the next section of the chapter 10, and we're going to be looking at modeling with graphs, which is actually the last section of the chapter. It's a short chapter, so I think we've done 10 chapters this year. That's not bad. We may have a look at chapter 11 next. Anyway, alright, so here we go. Modeling with graphs. I'm going to go through a couple of examples. This is all fairly simple, so you'll be fine. So this is where we're going to model a real life situation through a graph. So something like a trip, and how long does it take to go from point A to point B, and if we wait there and we come back, and what does the graph of that look like? It's building on from what you did last lesson. So here's the example. This is a classic example. I've seen it so many times. Jenny runs a bath. The water from the tap fills the bath at a rate of 12 liters per minute. So we're filling the bath at 12 liters per minute. She runs the bath for 10 minutes. So runs for 10 minutes. Question A. Work out the amount of water in the bath when Jenny has finished running it. Easy. If we are pouring, so if water is flowing at a rate of 12 liters per minute and we're running it for 10 minutes, so the answer to part A is 10 multiplied by 12, 120 liters. So we have 120 liters. There you go. And then Jenny stays in the bath for 20 minutes. So she stays for 20 minutes in the bath. She then empties it and it drains. So it drains at a rate of 15 liters per minute. So part B, work out how long it takes to empty the bath. So the answer to part B was we had 120 liters. It is draining at a rate of 15 liters per minute. So we're just going to divide it, aren't we? So 120 divided by 15. My calculator is propping up my iPad, so I'm going to have to do it by head. This is, if I divide both by 5, 120 divided by 5 is 24. This is going to be 8. It's going to take 8 minutes to empty the bath. And then part C says, draw a graph to show how the amount of water in the bath changes. So part C, I'm going to have to draw a bath where this is time and this is the liters of water in the bath. So we know that after 10 minutes the bath will be full and it will have 120 liters. And because it's flowing, the water is filling the bath at a constant rate, it's going to be a straight line from being empty here to being full. So it should be a straight line because the water is flowing at the same rate. Then we know that Jenny stays in the bath for 20 minutes. So from 10 minutes, another 20 is 30 minutes. So she is there. The amount of water in the bath doesn't change while she's in. We still got 120 liters. And then she empties it. We've worked out that it takes 8 minutes to empty the bath. So another 8 minutes takes me up to 38. The water is flowing out at a constant rate. So it's another straight line down to 38. And it should be a little bit steeper than that line there because the water is flowing out faster. And that's it. That's how I've modeled that situation of having a bath with my graph and doing a couple of calculations there. I'm going to show you another classic example from the book. I'm going to talk over it on the picture, and that pretty much sums up modeling with graphs. Okay, people, here we are. So here we've got 4 different containers, A, B, C, and D. they are being filled with water, and we need to match each container with the graph that shows the change in how much water there is in each container to the container. So if I just pick my pen here, okay, the easiest one is A. A is a cylinder, and because the water is being poured at a constant rate, and the shape of the container doesn't change, isn't it? It's just a cylinder. So this is just going to be filled at the same rate all the time. The level of water in the cylinder is going to be increasing at a constant rate over time. So that's going to be that one there. It's going to go on a straight line, isn't it? The amount of water in the cylinder goes steadily at the same rate over time. So there you go. Now, B, if you think about it, the water, what do you think is going to happen? Is the level of water going to rise at the same rate or at a different rate? It's going to rise at a different rate, because as I pour the water, the bottom of the shape is getting larger, isn't it? As the water fills the container, the bottom of the container is getting bigger. So the rate, so the speed at which the water is filling the container, is the speed of the water filling the container, is it going to go up or is it going to go down? It's going to be going down, isn't it? It's going to be going down. So I'm looking at potentially this, the depth is going to be slowing down. So it's either going to be P, it's either going to be the first graph, or graph R. All right. So which one of the two? Well, let's come back to it. In C, if you think about it, as I pour water in, at first the water is going to rise very slowly because there's a lot to fill in, but as the container, the base is getting smaller, then the water is going to be rising up quicker. So the depth of the water is going to be increasing quicker. So C is going to go with S, isn't it? The amount of water at first is increasing slowly, and then it's increasing more and more because the gradient of the line is getting steeper over time, isn't it? So that goes with that. And D looks a bit like C. At first, the water is going to be increasing very quickly, but then it's going to be slowing down because the shape of the container is getting bigger, isn't it? So out of P and R, which one is increasing very quickly at first? Is it R or is it P? It is going to be P. So this one, D, goes with P, and then the one we had out, B, goes with R. Okay? And I've explained the reasoning why. It's to do with the shape of the container. In A, the water just goes up at the same speed over time. Here, the water increases but more and more slowly every time, which is the same as here in D, but just not as slowly. So here I've got a slower rate of increase, and here it is slowing down at a much quicker pace. And then that one, first the water is going to go in slowly, and then it's going to end up going quicker because there is less surface to fill in, so it's S there. And that is another example of modeling with graphs.